Hey y'all, we are taking a look at the heart, but specifically we're going to take a look at the electrical conduction system of the heart. As you hopefully know, the heart, it can beat on its own. It's autorhythmic. It can get input from our nervous system on how to beat, but it can keep its own rhythm. So when you see those movies where you pull the heart out and it's still beating, it's kind of accurate. The heart can live and beat on its own, as long as it gets nutrients to do it. So in order for it to do that, we first have to start at this top right area. This is the right side of the heart. This is the superior right part. This green part is representing the Sinoatrial Node. Sino is referring to on top. This is the right atrium. You can see the auricle of the right atrium. This is the Sinoatrial Node, SA node. This SA node gets input from the sympathetic and parasympathetic nervous systems to speed up or slow down, but it does keep its own rhythm. A normal heart rate is roughly 60-70 beats per minute. Sinoatrial node can spread electricity to the atria through these myocardial cardiac contractile cells. There's electricity spreading through those gap junctions at the intercalated discs. But the nodal cells here also spread electricity to the next node. The next node is found between the right atrium and the right ventricle, shown here in green. This node is the Atrioventricular Node, AV node. So we go from the SA node to the Atrioventricular Node, AV node. The path, there's a direct path between these two. This is called an internodal pathway. From the Sinoatrial node to the Atrioventricular node, that's called an internodal pathway. The AV node is really important. It can generate its own signal, but what's important about these nodal cells is that they slow down the signal. I said that from the sinoatrial node, we have electricity also spreading to both atria. We want the atria to finish contracting so that we get as much blood as we can into the ventricles before the ventricles squeeze and pump out. We don't want any backflow of blood into the atria, and we want to maximize how much blood we're pumping out of the heart. So the AV node is really important for slowing down electrical conduction, to let the atria finish contraction, to finish atrial systole. After the atrioventricular node, we then get electricity spreading more inferiorly down the heart, but one big difference is as it spreads down, it's going to go all the way down to the apex before spreading through the cardiac contractile cells of the ventricles. We want the heart to squeeze from the bottom up, from apex to base. You can see how the contractile cells are arranged in a spiral formation. We want to squeeze apex to base bottom up to make sure we get as much blood out of the heart as we can. So that's why we send the signal down first and then have it spread through the cardiac contractile cells. So if you look closely, we have this little bundle here from the AV node, atrioventricular node, this little pathway. It's called the Atrioventricular Bundle. You may also see it called the bundle of His, but AV bundle makes more sense. It's between the atria and ventricles. This is the Atrioventricular Bundle, the AV bundle. The AV bundle then splits. It splits. So these are bundle branches. We have the right bundle branch and the left. Sorry, I said this the wrong way. This is the right, because this is the right side, right bundle branch and the left bundle branch. Whoops. All right, so these bundle branches will go to either side, and then they've reached the apex here. Then these branches branch even more to all those little branches that you see. These little branches then extend to the cardiac contractile cells of the ventricle walls. These are called Purkinje fibers. We've seen that name before, Purkinje. We saw that in the brain, and those dendrites, the neurons were very, very branched. These are branched also, but they're not neurons. They're special branches of myocardium. So these branches are Purkinje cells. Purkinje fibers. All right, to recap all that, we start at the SA node. That's where we generate a signal. We spread electricity through the atria, but we also send electricity from the AV node through an internodal pathway, from the SA node through an internodal pathway to the AV node. Sinoatrial node, internodal pathway, atrioventricular node. From the atrioventricular node, we get that slight delay through the AV bundle. Then we split to the right and left bundle branches. Bundle branches reach the apex, and then they go up through either ventricle. These are the Purkinje fibers. And then we get the ventricles contract, and they squeeze blood out of the heart, out of the pulmonary artery, pulmonary trunk, or aorta. All right, that is how electricity spreads through the heart to cause contraction. We want to alternate contraction of atria and ventricles. Let me know if you have any questions. Thanks for listening.